about solving exponential equations. Okay? So there's how do you make this work? Solving exponential equations. You guys are going to do some responding to some of these questions. Okay? So all of solving exponential equations is based on these two properties. Okay? First of all, these two properties. If a to the x equals a to the y, that means that x is equal to y, right? That x must be equal to y. So for instance, if I know that 2 to the 5th is equal to 2 to the x, what's x equal to? X is equal to 5, okay? This is stuff you don't want to write on the whiteboard yet. This is more like notes, okay? You also know that if log base a of x is equal to log base a of y, that also means that x is equal to y. Okay, so we're going to use these properties a lot. The other two important things to remember is we already talked about this, okay? That a to the log base a of x is equal to x, and log base a of a to the x is equal to x, because the logarithmic function and the exponential functions are inverses of each other. Remember how inverses work? If I have f of x and I have f inverse of x, and I were to take some number, say take 2 and plug it in here, and I get out 7. And if I take 7 and plug it in here, what do I get out? From the inverse? 2, okay? The function and the inverse undo each other, okay? It works in both directions. So if I were to take 2, plug it in here, I'd get out 7. If I were to take 7, plug it in here, I get out 2. So that's what this is talking about. Because if I take, so for example, if I have y equals 10 to the x, and log y equals log base 10 of x, right? Log base 10 of x. If I take 2 and plug it in here, what do I get out? What's 10 to the 2? 100. What's the log of 100? 2, right? You understand that? Right? Log of 100 is 2. So that's basically what this property says and what this property says, okay? In reverse. So now, look at this. Write all that down. No! Don't write all that down, okay? It's just the way that this is just giving you kinds of simple examples of everything that we're going to work with today, okay? So if 2 to the x equals 32, you want to rewrite these with the same base. So if I rewrite 32 as 2 to the 5th, that must mean that x equals 5, right? Understand that? Questions? No? This is in your book. If I know that log base 4 of x minus log base 4 of 8 equals 0, I can bring this over onto the other side, and therefore if these are both log base 4 and this is x and this is 8, that must mean that x is equal to 8. Same idea here, okay? This one's a little bit trickier, okay? Because, I mean, you can do it this way. What they did is they wrote 1/3. They recognized that these are both powers of 3. 1/3, right, can be written as 3 to the negative 1 power. Yes? Do you agree with me there? Okay? And so if I take 3 to the negative 1 power and I raise it to the x power, right, I get 3 to the negative x. And I can take 9 and call 9 3 to the 2 power. That must mean that negative x is equal to 2, or x equals negative 2. Yeah? Yes? Okay. No? Okay. Over here, we are working with, so let me just kind of explain this a little bit more, okay? So over here, this one, let me show you what they're doing here, okay? So they're kind of taking the log of both sides, but they're also taking the reason that works is because what you're doing when you're taking, what's the natural log of e to the x? What's the natural log of e to the x? X. Because this undoes this. So this is just equal to x equals natural log of 7. Yeah? No? Or you can think of it when we start doing problems, well, we'll worry about that when we get to it. Got log base 10 of x. I can raise log base 10 of x to the 10th power. This is called exponentiating. So I can raise log base 10 of the x. I can put a 10 down here. And so 10 to the this has to equal 10 to the this, right? Therefore, this goes away because this undoes this. And so you get x equals 10 to the negative 1, which is 1/10. And if they do a similar thing here. We'll get some practice with these. All right, so now I'm going to give you an example, and then we're going to do some. Does anyone need to write all this down? Or okay? Can I move on? Can I move on? I can move on. 3 to the x equals 81. Who knows the answer? Oh, that's too easy. Who knows the answer? Yes? 4. Yeah, no, yes. Okay. So how can I write 3 to the, I guess I should have had you do that. Okay. How can I rewrite 81? 3 to the what? 3 to the 4th power. So I mean, some of you might have done this in here. Well, 3 to what power equals 81? 3 to the 4th power equals 81. Or I can rewrite this using that 1-to-1 property. If I rewrote this as 3 to the 4th, therefore x must be equal to 4, right? Okay. Another way to think about this, no, let's not worry about that. Okay, your turn. Your turn. Solve. Leave your terms in leave your answer in terms of leave your answer in terms of a logarithm. Okay? Whoa! Sorry, what's wrong? Handy that cat. It's pink. Where'd you get a pink marker? Found it? Try this one. Solving the x equals 45. On your whiteboard. Wait. I have to pause. I have to make it big. So going back to this, am I recording now? I'm recording. Okay. So if you so you can log both sides. Go away. Okay. You can log. So you can natural log both sides. You can take the natural log of that, and natural log of e to the x is just equal to x equals natural log of 45. Okay, you guys want to try this one? This one looks hard, but it's not very hard, no. Leave your answer in terms of a logarithm, okay? It says round to the nearest hundredth, but why don't you guys just try and leave your answer in terms of a logarithm, okay? Ready, set, and go. Again, yeah, we'll ask him to give you guys some charity points, okay? But you can divide by 4 both sides, okay? That's what I would do first. E to the 2x equals 4. Then you can logarithm both sides, right? So this makes this go away. So you get 2x equals natural log of 4, which gives you x equals natural log of 4 divided by 2. You cannot divide natural log of 4 by 2 and get natural log of 2. It doesn't work that way, okay? Because natural log of 4 is divided by 2 is not the same as natural log of 2, okay? Okay, so you have to leave it like that. You can put that in your calculator and you can get some nice answer. All right? So let's move on. Let's move on to this next one, which says, what does the next one say? It says, try to solve this, okay, as if solve for x. Give it a shot, okay? See what you can do. Solve for x. Whoa, what is he doing? He's trying to pause this. Okay, so if you did this, probably you just you should have gotten you had 8, right? So you get e to the x plus 2 equals 22 divided by 5, right? Then you take the log of both sides, right? And this goes away, and you get x plus 2 equals natural log of 22 over 5, and x equals natural log of 22 over 5 minus 2. So what Garrett did, he rewrote this as natural log of 22 minus natural log of 5 minus 2. That's fine. That works. Okay? Okay. So try this one. Try this one. Go ahead. There's no e. That's right. But there is a 10. How do you get rid of a 10 to the x? Yeah, you do. Okay. Well, where'd they go? Where'd they go? There. So what I would do first in this one is just divide by 6, right? Is that what you did? So I divided both sides by 6, which turns this into 10 to the x equals 36. To get rid of 10 to the x, you log base 10 it, okay? But if I log base 10 that side, I got to log base 10 this side. This disappears. Log base 10 of 10 to the x makes those things go away, and you get x equals log base 10 of 36, which just is log of 36. Yes? Okay, we're good with that one? Let's move on. Let's move on. We're almost done already. You want to try this one on your own? Try this one. Try this. Okay, wait. I have to take a picture of it. Otherwise, it's going to go in. Partial. No, I'm going to do the example, and then you can check. So, if I were doing this one, first what would I do? You don't have to do this. Divide both sides by 2. Divide by negative 2, positive 2, right? And then I get 3x minus 1 equals 5. Then what? Then I get 3 to the x equals 6. Now what? So now I can log base 3 it, right? Log base 3 of 3 to the x is going to make that go away, right? Log base 3 of 6. Log base 3 of 3 to the x is just equal to x. And your answer is log base 3 of 6, which you might write if you want to find that on your calculator. How would I find that on your calculator? You would say that that's equal to, you do log of 6 any base over log of 3. Get it? You could do ln too. Okay? Okay? Okay, so now I think I have a you try. Do I have a you try? Try this! Because it is. Because you guys are pretty good, okay? So this one's a little bit tricky, but give it a shot. I would first solve for this thing over here, right, in the brackets. And when you do that, you get 2 to the 3 minus x equals, what do you get? Add 13, you get 113 divided by 5, right? Hello? Okay. Now you log base 2 both sides. Log base 2 of that. And this goes away, right? So you get 3 minus x equals log base 2 of 113 over 5. Then what I did, I brought the x onto this side, and I brought this onto this side, right? And if you do that, you solve for x, you get x equals 3 minus log base 2 of 113 over 5. And you can plug that in your calculator and get an answer, Okay. What else do we got here? Okay, so this is the last one. I'm not going to ask you to do that. I'm just going to show you how to do this one. We're kind of done with the whiteboard. You like the whiteboard?
Can we try first?
It's spark. That was the intent. Okay, to spark your participation. You guys want to try this?
Yes.
I'll give you a hint. Okay. Yeah. See how this kind of looks like a quadratic equation? Okay. Here we go. Let e to the x equal y. That means that e to the 2x, or y, what would y squared be? What's e to the x times e to the x?
EX squared.
E to the, not ex squared, you would add the exponent, e to the 2x. So y squared equals, so I would do a substitution here. Rewrite this equation like this, and then then factor it, and then solve the equation. Okay?
What's the answer?
I'm not telling you yet. Okay? What's the answer? Not telling you. That's right. And you rewrote this as y squared minus y minus 20 equals 0, right? And then you factored that, and you get y minus 5 times y plus 4, right? Equals 0. So y equals 5, or y equals negative 4. And then you rewrote it as e to the x equals 5, or e to the x equals negative 4, which tells you that x equals natural log of 5, or natural log of negative 4. Negative 4, sorry. Can you take the natural log of a negative number? No, okay? Because, look, just remember this, okay? There's an e down here, right? So there is no number that I can raise e to and get a negative number. So this answer, it's outside of the domain of natural log, so you have to throw this one away. Okay? So you throw that answer, natural log of negative 4 away. Got it? But most of you are fine with that, right? That's it. You have 45 minutes. You can do all your homework. Oh! I'm not done yet. Sorry. We do have one. Sorry. I'm not done yet. I take that back. This is kind of a fun one. I'm going to do an example, then you're going to do one. Got it? So, if you are investing, how long will it take for an investment to double if the interest is compounded continuously at 8% a year? Okay? So, turns out you don't, this formula, Drew, shush, okay? Doesn't matter what you call this. I'm just going to call this P, okay? If my amount doubles, how much do I have over on this side? 2P, right? E to the, what's R in this case? 0.08 T, okay? Watch what happens to the P's. What can I do with the P on this side, P on that side? Cancel out, right? P's go away, so you get 2 equals E raised to the 0.08 T. How do I solve that? Natural log both sides, right? Natural log of 2 equals natural log of e to the 0.08 t. So this goes away, so you get 0.08 t equals ln2. So t is equal to ln2 divided by 0.08. If you do that on your calculator, I think you get about 8.6 years or something like that. Okay? Do you understand that problem? Questions? Okay? So, you try. Ready? Ready to try one? Ready? Set. Last problem. You try. How long did it take for you to, how long would it take for you to triple your investment? If invested at 25% here, round to the nearest here. Okay? That's all. You can do that, right? Oh, I just did this problem for those of you in our viewing audience. Okay? Yes, we're done. This is your homework. There it is. You can